Hi, what's going on, folks? My name is Patrick. Today, we're going to learn how to create our own custom license plate recognition model using Torch, which is a PyTorch module. So, just to give you a brief overview of what we're going to create today, it's just a model that will be able to recognize our number plates, including annotating them. And after we're going to expand our project using Tesseract so that we can record all the number plate details. So, essentially, this is how the end model will look like. So we're gonna have to upload an image here. Say this one here. Yeah, so what essentially the model does is that it will be able to annotate the image by labeling the Arabic numbers, the Latin numbers, the logo. So we're going to use a complex number plate, the Saudi Arabian number plate in this case. So to get started, let's first open up our YOLO annotation tool, which is available on the internet. So after that, we need to create our text, the classes text, which means that we are just like trying to teach the model what to recognize in the images. So for this case, I'm just going to load some text file that I created. Yeah, so we've got around 6 features. We've got the full plate, we've got the Arabic numbers, Latin numbers, Arabic text, Latin text, and the Kingdom of Saudi Arabia number plate logo. So after that, I'm going to now start to annotate my custom images, the number plates. Yeah, so for the number plates, I'm just gonna head over and click on the full plate class, and after that, I'm going to draw a notation to indicate what our full number plate looks like. And here we go. And after that, I'm gonna head ahead and click on the Arabic numbers. So we've got the first set of the Arabic numbers here, all like that. And after that, I'm going to annotate the Latin numbers too, and Arabic numbers as well, and the Latin text too. And lastly, I'm gonna annotate the Kingdom of Saudi Arabia logo like that. So after that, I'm going to save the annotation as a Coco so that I can have them in form of XML format, which makes it easier for me to annotate and also to read them. So let's see how it looks like, how the file looks like. Well, taking too much time to load. I guess something is wrong with my computer today. Well, I can see we saved it in JSON format, which is not the format I expected. I need it to be in XML format, so I'm gonna download it in the form of VOC format, and let's see what we got. Yes, so let me try to download it again so that it doesn't overwrite the existing files over here. So I'm just going to we download it. And this time I'm gonna open it on my downloads. See if I can get both. Yeah, so here we go. As you can see, we've been able to annotate the car underscore 5 image in XML format. And as you can see, we've just saved the file just with the same name as the JPEG format. So I'm going to do that for the next around 190 set of images, and the end product will look something like this. So at the end, we shall have a list of around 190 XML formats of those images, and now we have. I think it's enough. The dataset is enough to get the training started. And for this case, we're going to use a collaborator in Google, and we're gonna have to turn on our hosted runtime as to use a GPU, the T4 GPU. And after that, we're going to create a code that uses PyTorch to deep train our dataset. And that way, our model will be able to recognize our images, though it will be able to annotate all the images as long as it can read the details. And it has been trained to all the details. It has been trained. Well, we have a limited number of data sets. In this case, we've got around 190 sets of the data of the number plates, which definitely isn't enough to train a production level model. But I guess it gives us an overview of what we can try to do, of how it is done. So we begin, as always, by installing the necessary modules, and after that, the next section is to import those modules, all the requirements, and after that, I saved all those files in my Google Colab so that I can read them by just using the drive.mount content Google Drive here. And after that, I'm just like defining the label mappings that we have in our number plates. And after that, what I'm gonna need to do is to map the content of the annotations with the number plates. So this tells the torch or the deep training module to learn from the annotations what exactly represents the full plate, or maybe the Arabic numbers, what the representations of the Arabic numbers are from the annotation, XML annotation, and that way it can learn from the training how to identify number plates, the content of the number plates, or how to annotate other number plates just from learning from the training session. So as always, we've got to convert the images into tensor format so that they can be read by the torch. And after that, this is just we're like defining and ensuring that our annotation, the XML format, is actually the box is actually mapping. We are actually mapping up our images and the labels as well. That is essentially what happens in this case. And after that, we are creating a class of number plate dataset with annotation and the image. And after that, we have to call this function here. So after that, this is just some boxes that we have defined to ensure that all our images or our module can train them using the same width or height, so that it doesn't have to we don't ruin it, and so that it is able to learn swiftly by just recognizing the same size. So what happens is that the images will be created on a scale of 0, 2, and 1, 3 format, and we shall see that just below this one when I will take you through that later. and simply we are just like training the data set here, and we are also like fine-tuning the model here using the first RCNN predictor, and we are also turning on the CUDA, that is the GPU in this case, and after that we are running the training and validation functions here. And for here, this case, we are concerned about training the loss or reducing the loss. And that is what exactly will happen when we define our epochs here. We are defining them to 5 so that it can run faster. Of course, this is not the right way to do it. You should try to retrain it as much as possible. Remember that the more the training or the more the time you take to train a model, the more accurate it could be. But it's not always the case, especially when hyperparameter tuning will definitely work better than trying to increase the number of epochs. But we did this to make sure that our model runs faster, or the training procedure runs faster, and doesn't take so much time. Yeah, so as I said initially, so we are like trying to define our mappings and ensure that all the images passed through the training have of the same size. So this ensures that we are able to kind of like annotate them correctly, because we have defined them to have the same size. So this means that the drawings will definitely have to fall within those mappings that we've defined just up there. So as you can see, our model is trying so far. We were able to. It is trying so far. It is able to annotate the Arabic numbers, Latin numbers, and the Latin text as well. Well, not so accurate, but at least it's giving it a shot, as you can see. So the next thing would be to create or maybe to create more annotations or maybe more images and try to retrain it and see if the accuracy can improve. So aside from that, we are, as I said, initially we're going to run an external. We are going to save the model into our notebooks, and after that, I'm going to load it here and see if at all the model has been trained to recognize the content in our number plates. So I'm going to run another image and see if that works. Let me try to check another image. Yeah, so as you can see, it's not super accurate, but at least it gives us an idea of how the trained model works, or maybe how it's how it looks like, and how accurate it can be if more training is done. So basically that's the end of today's tutorial, and I hope you like it. Thanks.